starting Chapter 6 with Section 6.2, and we will spend a total of 3 days on this section. It is solving trigonometric equations, and to start us off, you will need your calculator, and I would take out a unit circle to just go through these first two examples. So taking a look at the first example here, it is back from unit circle material, so it says sine of theta equals root 3 over 2, and we want to know what values of theta are going to make this equation true. And I'm going to go through a little bit different of a thought process than we did in the unit circle. The first thing that I want you to think about is, where is sine going to be a positive value? Well, sine is a positive in both quadrant 1 and quadrant 2. Back to all students take calculus. If you look on our unit circle, you will notice that the sine value, or my y coordinate, is root 3 over 2 at two spots, 60 degrees as well as 120 degrees. Now think about what those angles tell me as far as a reference angle. Now I'm going to draw this down here. I don't believe you have room on your note sheet, but just kind of watch. I'm going to show where 60 degrees and 120 degrees falls. Once again, that's in quadrant 1 and quadrant 2. If I'm in quadrant 1, here's my 60 degree angle. And the reference angle at 60 degrees, remember, if we fall in the first quadrant, that's your reference angle. 60 degrees. Similarly, I could have found my reference angle off of that second answer of 120 degrees. Again, start at 0. I'm going to go all the way to 120 degrees. And remember, we found our reference angles by acknowledging the fact that one whole half rotation around brings me to 180. That reference angle always falls between your terminal side and the x-axis. So here's my reference angle. And how do I find that? Well, if that angle were to fall in the second quadrant, we say 180 minus 120, and that gives me 60 degrees. So again, I get a 60 degree angle as the reference angle for example 1. You should always have the same reference angles for your different solutions. And in this case, we have two solutions. Looking at example 2, same idea. Now I have a cosine function. The cosine of theta is a negative root 2 over 2. Well, where does cosine give me a negative value? That happens in quadrant 2 and quadrant 3. And if we look at our unit circle, my cosine value is a negative root 2 over 2. That is, the x-coordinate is a negative root 2 over 2 at two spots, 135 degrees and 225 degrees. Well, what's the reference angle at those two spots? It's 45 degrees. Okay, moving on to angles that might not fall on your unit circle. So what happens if the sine of theta equals 1/3? Well, you look on your unit circle, you're trying to find a y value of 1/3, and you can't find one. So what do? You turn to your calculator. And I've got the steps listed here. I'm going to kind of go through that on the next slide, though, at example 3, so you can read through this on your own note sheet, and I'm going to slide over to my next page here. So a same question, find all solutions to the following equation given theta falls between 0 and 360. Notice your interval here. I do want to include 0 if I happen to get that as a solution, but I'm not going to include 360 because it's less than that. And we're always going to round to the nearest hundredth, which is two numbers after my decimal. So you learned this back in geometry, but if you do not remember, the sine of theta equals 1/3. We want to get rid of this sign. We want to undo that sine function, and the only way to do that is to apply the sine inverse. So what you end up punching into your calculator is not just the sine key, but you need to press second sine, which will pull up sine inverse. So on your calculator, press second, press sine, and then follow that with whatever the number is here, 1/3. So on your calculator, also make sure you are in degree mode. So your mode is one of the top buttons. Make sure degrees is highlighted, not radians. If it's not, go over and highlight degrees. For all these answers are going to be thrown out. So I'm going to do second sine of 1/3. Whatever you get from that value directly will spit out your reference angle. So this equation here gives me 19.47 degrees. That is your reference angle. Now these first two lines are guiding us to that final answer of what theta is. So we want to know, where does the sine of theta equal 1/3? First, think about what quadrants can sine be a positive 1/3. Sine is positive in quadrants 1 and 2. Reference angle, which we just found, is 19.47 degrees. And then to find out what my values of theta are, and you will most likely have more than one solution, I'm going to graph it first. We're going to go ahead and graph an angle in the first quadrant, connect it down to that x-axis, and in the second quadrant, connect it down to the x-axis. Now that 19.47 is my reference angle, which means here is a 19.47, and here is a 19.47 degrees. In quadrant 1, your solution is your reference angle, so this happens to be one of my answers. In quadrant 2, how am I going to find what that whole angle is? Well, just think about it graphically. If I start at 0, I'm going all the way around. How far until I hit this line here that forms that 19.47 reference angle. Well, if that whole thing is 180, I want everything but 19.47. So to find this angle here, we're going to say 180 minus 19.47 degrees, and that gives me my second answer of 160.53 degrees. Moving on to example 4. Cosine of theta equals negative 1/3. Now you may have noticed in the notes above, it does tell you that when things are negative, your calculator gets a little funky. So what I want you to always do, just to be safe, is just plug in positive. Just plug in that ratio 1/3. Don't worry about the positive or negative. That's where when we let this our quadrants, it helps us out. So where does cosine equal a negative 1/3? Well, cosine is going to be negative in quadrants 2 and 3. I need to find my reference angle. So let's undo this function here with the inverse, cosine inverse of 1/3. And again, just plug in a positive 1/3. Sometimes it'll give you the reference angle right out, sometimes it doesn't, and it's just easier if you plug in the positive version of it. We get a reference angle out of 70.53 degrees. Now again, think about where this is graphically. I'm in quadrants 2 and 3. Here's my angle in quadrant 2. Here's my angle in quadrant 3, where that reference angle is 70.53 degrees. Again, in between the terminal side and the x-axis. So to find my solution in quadrant 2, I need to say 180 minus 70.53, which gives me a solution of 109.47 degrees. Then my solution in quadrant 3, well, that one has gone around half of my unit circle, which is 180, and then we kept going for an additional 70.53 degrees. So for this one, I need to go ahead and add that reference to 180 instead of subtracting. That gives me my second solution, which is 250.53 degrees. Okay, let's go ahead and move on to example 5. So if you haven't gotten all of this down, you might want to go ahead and pause the video. Otherwise, we're moving on. Example 5 is slightly different. Now I have a cosecant equaling negative 5.3. Well, I don't have a cosecant or an inverse cosecant button on the calculator, so what we want to do is use reciprocals. Well, if the cosecant of theta is negative 5.3, then the sine is the reciprocal of cosecant, so sine will give me negative 1/5.3. Once again, let's jump down to the first blank here. Where is sine or cosecant negative? Well, that's going to happen in quadrants 3 and quadrants 4. To go ahead and find my reference angle, I want to once again do inverse. So sine inverse of, don't plug in the positive, just plug in, don't plug in the negative, plug in your positive. Sine inverse 1 divided by 5.3. That will give you a reference angle, 10.88 degrees. Well, in quadrants 3 and quadrants 4, to find my solution, I want to first take 180 and add that reference angle. I get 190.88 degrees. For quadrant 4, let me draw this one because we haven't done a quadrant 4 one yet. Think about your reference angle, 10.88, quadrant 4. Well, what's that as a solution? I've gone around almost an entire circle, except we are 10.88 degrees shy. So to find this, I'm going to take 360 and subtract 10.88. Gives me my second solution, 349.12 degrees. And number 6, the only thing that's different about this one is that I have a lot more numbers on the left-hand side. The first step is to get that function completely by itself. So let's go ahead and get rid of that 2 first. I have 10 tangent equals 22 minus 2 will leave me with 20 on the right. Go ahead and divide by 10, and we're left with tangent equaling 2. Well, where is tangent going to be positive? That's quadrant 1, quadrant 3. If we punch this into our calculator once again, to get theta all by itself, I'm going to do tan inverse of 2. And I get a reference angle of 63.43 degrees. If I want to find my solution, in the first quadrant, your answer is 63.43. And in the third quadrant, I need to add that to 180. Gives me 243.43 degrees. Okay, moving on to the next slide. Once again, pause if you need to get any of this down. And go ahead and switch to the back side of your notes. I'm going to skip example 4. Yes, I'm sorry, example 4 starts over again. Look on over to example 5. The secant equals 0.5724. Once again, that is a reciprocal function. So let's change this to, instead of a secant, reciprocal is cosine. And then if I flip the function, I need to flip what it equals, 1 over 0.5724. Now go ahead and plug it into your calculator. Second cosine inverse of 1 divided by 0.5724. And what happens? If you're plugging this in correctly, you should be getting an error. We can't take the cosine of any angle and spit out this value of 1 over 0.574. In this case, I don't have anything to add here. We have a no solution. You can either write no solution or a 0 with a slash through it. And make a note to yourself, why did this happen? Well, remember the values that cosine can equal, the values that secant can equal. Sine and cosine can only have values that fall greater than or equal to -1, less than or equal to +1. And in turn, their reciprocals cannot have values that fall between there. So I could have noticed from the start that secant cannot give me some decimal, 0.57, or you might notice from here that cosine cannot give me a 1 over 0.5724. That goes beyond the bounds of both those functions. Okay, let's do one more. So switch on to example 6. We have 4 tangent of theta plus 3 equals 2. Once again, you need to get that function completely by itself. Think about it as just a variable. The first thing I want to do is subtract my 3. 2 minus 3 gives me a -1. And then I can go ahead and divide. Tangent theta equals -1/4. Once again, jump down to your blanks or guide us towards our answers. Where is tangent a negative value? Well, that's going to happen in quadrants 2 and quadrant 4. To find my reference angle, turn to your calculator and do tan inverse, so second tangent of, don't plug in the negative, make it easier on yourself, and just plug in a 1 over 4. Out comes your reference angle, 14.04 degrees. To figure out our solutions, once again, that's just the reference angle. My solutions fall in quadrants 2 and quadrants 4. If I'm in quadrant 2, I need to say 180 minus my reference angle. We get 165.96 degrees. To find the solution in quadrant 4, take 360 degrees and subtract that reference angle of 14.04. You should get 345.96 degrees. And that is the end of 6.2, day 2.